The figure on the right shows a right triangle with acute angles at A and B, and a right angle at C. Of course, we can always say that that angle is a right triangle if there is a box provided. That is somehow the way we differentiate the different angles. The box, we associate it with 90. Now the length of the side opposite to angle A. So if this is our angle A, opposite to A is small letter A, this one, right? And the length of the side opposite to angle B, this is angle B, opposite to B is small letter B. And the length of the hypotenuse for our two angles is small letter C. By the preceding definitions, sine A, which is sine opposite over hypotenuse for A, while the for our B, if we want nga magkapares sa A over C, ang cosine ni B, cosine is adjacent ni B is A, and hypotenuse. So cosine B is equal to A over C. Thus, we have the following identity, and that is sine A, and not really identity, but the following definition. Sine sine of angle A is equal to A over C, opposite over hypotenuse, is equal to cosine B, which is adjacent over hypotenuse. Only the side opposite to angle A is small letter A, and the side adjacent to angle B is small letter A. So that is why we're able to equate sine A with cosine B. Now, similarly, tangent A is A over B, and cotangent B is A over B as well, while secant A is C over B, and cosecant B is C over B. Cosecant being the inverse of sine. Sine B is B over C. So inverse na that's C over B. So unsa may importance ani? Now, in any right triangle, the sum of the two acute angles is 90 because the total sum of all the interior angles of a triangle is 180, di ba? So, if right triangle siya, one angle is already 90. So, therefore, the remaining two angles, which are acute angles, is equal to 90 para 90 plus 90 is equal to 180. And if the two acute angles are equal to 90 degrees, it means that these two acute angles are complementary with each other. So in the figure, A and B are therefore complementary. And we have established based on this illustration definition here that sine A is equal to cosine B. So therefore, this can also be written as sine A is equal to cosine of 90 minus A. So say for example, if we have uh, 30 and then this is 30 and this is 90, by definition, this second acute angle here, it should be, let us say this is theta. Theta is equal to 180 minus 30, and this 90 here minus 90 is equal to 60 degrees, right? So in another way of saying that, it's theta is equal to 90 minus 30. So if we say A is 30 degrees. So if you say A is equal to 30 degrees, and then so that is sine 30. So the cosine would be 90 minus A, that is equal to 60 degrees. So cosine 60 degrees. So if you're going to show 30 plus 60 is equal to 90. So therefore, 30 and 60 is complementary. And if you guys bring out your calculator, you press sine 30, you will get 0.5. And if you press cosine 60, you will also get 0.5. So to sum, we call them co-function identities. That for any acute angle A, the following holds true, that sine A is equal to cosine 90 minus A. So of course, if equal si sine A to cosine 90 minus A, si cosine A equals sad ni sine 90 minus A. So say for example, if we go back, we have established that sine 30 degrees is equal to cosine 60 degrees. If we say cosine 30 degrees, that is also equal to sine 60 degrees. Okay? And then second A is cosecant 90 minus A. At the same time, cosecant A is secant 90 minus A. Tangent A is cotangent 90 minus A. And at the same time, cotangent A is equal to tangent of quantity 90 minus A. And the cofunction identities state the following. Cofunction values of complementary angles are equal. Again, cofunction values. But that doesn't mean complementary angles are equal. The values of the cofunction, yeah, mo equal. Like sine 30, which is 0.5, cosine 60 is also 0.5. Cosine 30 is square root of 3 over 2, square root of 3 over 2. So sine 60 is also square root of 3 over 2. Knowing that, let us do example 2. Write each function in terms of its cofunction. So if cosine 52, that is, and letter B tangent 71 degrees, and letter C secant 24 degrees. So cosecant for letter A, that is cosine 52 degrees. So if you say A is equal to 52 degrees and cosine A is equal to sine 90 minus A. So cosine 52 degrees is equal to sine of 90 minus 52 degrees. So cosine 52 degrees is equal to 90 minus 52, and that is 38. Sine of 38 degrees. So if you want try to check sine of 38 and then cosine 52, it has the same value. For letter B, we have tangent 71 degrees. If A is equal to 71 degrees and tangent A is equal to cotangent of 90 degrees minus A, so tangent 71 degrees is equal to cotangent 90 degrees minus 71. So tangent 71 degrees is equal to cotangent 90 minus 71, that is 19 degrees. Tangent 71 is 2.9042, and then undivided by is 2.9042. Again, we don't have a key a key in our calculator for cotangent. What we can do is we know from the identity that cotangent theta is 1 over tangent theta. So in order for us to check whether tangent 71 degrees is equal to cotangent 19 degrees, you have to use this formula, 1 over tangent theta. So what you're going to do, that is 1 over tangent 19 degrees. Okay? And you will have 2.904, so on. Value. Letter C, secant 24 degrees. If A is equal to 24 degrees, and then, so therefore, secant 24 is equal, sorry, let me erase that. Second A is second A is equal to cosecant 90 minus A. So secant 29 degrees is equal to cosecant 90 minus 24. So secant 24 degrees is equal to cosecant 90 minus 24 is equal to 66 degrees. Okay. Next, find one solution for each equation. Assume all angles involved are acute angles. Okay, so cosine of quantity theta plus 4 degrees is equal to sine of 3 theta plus 2 degrees. And letter B, tangent of 2 theta minus 18 degrees is equal to cotangent of theta plus 18 degrees. Now, cosine will only be equal to the sine of that angle if the angles are complementary with each other, right? Like what we have presented a while ago, that for letter A, sine A is equal to cosine B if A plus B is equal to 90 degrees. So therefore, cosine of theta plus 4 is equal to sine of 3 theta plus 2. Theta plus 4 plus 3 theta plus 2 is equal to 90 degrees. Theta, we arrange like terms. So we have theta and 3 theta. So that's theta plus 3 theta plus 4 plus 2 is equal to 90 degrees. 4 plus 2, that's 6. Theta plus 3 theta, that's 4 theta is equal to 90. Subtract both sides by 6. So this becomes 4 theta is equal to 90 minus 6. 90 minus 6. Let me bring this up here. So 4 theta is equal to 90 minus 6. That's 84. Divide both sides by 4. So theta is equal to 84 divided 4 is equal to 21 degrees. So this is theta. Only then theta plus 4, that's 25. 3 theta, that's 21 plus, no, 21 times 3. 21 times 3, that's 63. Plus 2, that's 65. 65 plus 25 is equal to 90 degrees. So to check, if A is equal to theta plus 4, that is equal to 21 plus 4 is equal to 25. If B is equal to 3 theta plus 2, that is 3 times 21 plus 2, that is equal to 65. A plus B is equal to 90. Yes. 25 plus 65 is equal to 90. Then letter B. So we will not go with this lengthy solution. We just say that tangent 2 theta minus 18 degrees is equal to cotangent theta plus 18 degrees. So that is 2 theta minus 18 plus theta plus 18 is equal to 90 degrees. We arrange 2 theta plus theta minus 18 plus 18 is equal to 90 degrees. Negative 18 plus plus 18, that's 0. Then 2 theta plus theta, that's 3 theta is equal to 90 degrees. Divide both sides by 3. Thus, theta is equal to 30. So theta is equal to 30.